1957, there was an explosion in Kishtim in the Mayak facility at Chelyabinsk, and that was an explosion related to fuel rods, which melted down in a nuclear waste repository, and the explosion contaminated, I think it was 1,000 square kilometers of land, which became completely isolated. Nobody could go in there. It was highly radioactive. So it is entirely possible that there might be an explosion, but I think actually in the case of this, unless the plutonium concentrations get high or become separated in some way, then probably there won't be an explosion. There'll be like a sort of ongoing explosion, if you like to think of it like that.
Well, that was my next point, is that I've read some physicists say that if they are able to separate out the plutonium, the uranium, and then other isotopes, that you can get some type of actual chain reaction. Then I've had other physicists on who say that they don't think that was possible, but the same physicist said he didn't think 5 or 6 could have a meltdown because they'd been shut down before the event, and 5 has now.
I don't think anybody knows quite what happens at these temperatures under these conditions, and there are all sorts of parameters that have never been involved before, like seawater, like sodium chlorides, like molten salts, all sorts of things that would never have been experimented on. So in principle, it might be possible for, if the plutonium to separate from the general mix, for there to be a Kishtim-type explosion, in which case it would blow all this stuff, vaporize all this stuff up into the atmosphere, and then we would really be in deep trouble. So there might be some argument, and I think maybe this is why there was this panicky, hysterical decision to bomb them into the sea. But maybe there's some sense in that. Who knows?
Okay, final question, and we're going to let you go, Dr. Buzzley. We appreciate the time. Looking at this situation at Fukushima, I know you don't like to look into the future, but they've said it could go on for months or longer. I mean, from researching this, from seeing other cases, how long do you think it could go on, A? And then B, we see reports of governments and the UN saying that Chernobyl in '86 was 400 times a Hiroshima. Why are reactor meltdowns so much more dirty than an atomic or hydrogen explosion, or is that wrong?
Yeah, no, that's right. They are more dirty, and the reason they're more dirty is because they have vast amounts of uranium. I mean, the atomic bomb at Hiroshima was a limited amount of uranium. I don't know, kilograms, maybe a ton total. What we're talking about here is several thousand tons. I mean, the number of spent fuel rods there, as I understood, it was about 1,700 tons of spent fuel, and each of these reactors probably contains about 100 to 150 tons of uranium and plutonium and mixed radionuclides. So there's just a lot more stuff. That's basically it. The Chernobyl accident, which I think actually now, having talked to some Russians last week in Berlin, was a nuclear explosion and not a hydrogen explosion, because there was a particular fission ratio of xenon isotopes which defined it as a nuclear explosion. That one vaporized at very most 200 tons, and the argument was that it was only 50 tons. Well, here we have a lot more than that. We have a huge amount of fuel here that can go up in the air, and a lot of it already has.
So clearly, from the Russian example, some type of chain reaction is theoretically possible. Again,
No, that is right. The Russian explosion, which everybody has said, and they still are saying, was a hydrogen explosion. I talked to some Russian nuclear physicists last week in Berlin, and they showed information from the Radium Institute in St. Petersburg. They measured the isotopes xenon-133 and xenon-133m, and the ratio between those two isotopes defines whether it's a nuclear explosion or whether it's just a nuclear fission inside a reactor. It's either 22 or it's 12, and I think it was 15. So in other words, it was mainly a nuclear explosion, Chernobyl, not a hydrogen explosion, as they said. And my belief is that these also have been nuclear explosions and not hydrogen explosions.
Whoa, I said last question, but this is bombshell. You're out there, you're on major boards in Europe, you're talking to top nuclear engineers, and not only does it look like there was a nuclear explosion at this 50s event in Russia, they're saying Chernobyl was really some type of atomic chain reaction.
Correct, absolutely so. The definition is based on the measurements of xenon isotope ratios made at the Radium Institute in St. Petersburg. It was given as a paper by 2 Russian nuclear physicists from that institute last week in a Chernobyl conference in Berlin, where I was talking.
Dr. Busby, can I ask you a favor, or a favor for humanity? I want to have Kurt Nimmo, one of my writers, right now. We'll call him up here and call you back at home or your office, or can you send to an email we'll give you maybe a 2-paragraph write-up to make sure we get the isotopes correct?
Yeah, sure. They are xenon-133 and xenon-133M, which is a metastable isotope of xenon.
Sure. It's just my writers, because they're not nuclear physicists or chemical physicists, don't like to do this.
ChristaGreenAudit.org. Okay? Have you got my email? Or c.busby@ulster.ac.uk.
Yeah, what we're going to do, sir, is we're going to give you our email, and if you could just write up in 2 paragraphs what you just said. Jaron, will you put Dr. Busby on hold and here in a moment and give him your email? And just because when the show ends, sir, I'm going to go write an article with Kurt Nimmo. How fast can you send me just 2 paragraphs to be put in the story?
Well, I could do it in 5 minutes, I guess. Okay,
well, that's very gracious. Anything else you'd like to add, we'll put it into a story, because you are highly respected, one of the chief advisors to the BBC as well. Just in closing, because you said something very powerful there, you're saying, and you've been proven completely right in your analysis of the last month and 2 days, you're saying, sir, that evidence points towards chain reaction, some type of atomic explosion in and around Fukushima, and that's what you're saying?
No, I'm saying that Chernobyl was a nuclear explosion. I'm saying that there's no evidence that there was a nuclear explosion at Fukushima, but my belief is that there was, okay? So we don't have evidence for that. We would have to have the xenon isotope ratios. But what I am saying is that all of this talk about hydrogen explosions and Chernobyl being a hydrogen explosion is not true for Chernobyl. Chernobyl was not a hydrogen explosion. It was a nuclear explosion.
Okay. I understand that, and what really puts the cherry on top of or the coup de grace of this whole thing is that they will never release the actual isotope readings, we've noticed, and for 3 weeks they wouldn't release anything for the 2 prefectures in and around Fukushima, which they now admit they didn't release because they didn't want to scare people, and that adds weight to what you're saying. If they don't want to release the exact isotope readings, that's because they don't want the fingerprint of atomic chain reaction.
Maybe so, but my feeling is not that. My feeling is that they don't want people to know how much plutonium and uranium there is floating about, because that's the really dangerous stuff. All this iodine is the focus on iodine is a red herring in a way, and even on cesium-137, the really seriously dangerous isotopes are the uranium isotopes and the plutonium, because they are alpha emitters, and they come along as particles, particulates, so they float about the place like little hot coals, and then when you inhale them, they go inside you and produce massive doses to the local tissue. That's the problem.
Okay, we'll do this.
It's those particular alpha emitters that we need to know about, and we certainly need to know about them in the United States as well, because if there's a slight increase in iodine, it could well be that's associated also with the existence of these airborne particles, and it's the particles that are the problem. To say nothing of the tritium, we haven't heard about the isotope tritium, which will be produced in massive amounts as tritiated water, which sort of radioactive water. I would like to know very much what the tritium level is in the tap water in Tokyo.